Vincent mentioned, piecewise function is where we have bunch of pieces. Let's say I have 0 to 1, 1 to 2. And first piece is between 0 and 1. Try to keep this simple. The next one is from 1 to 2. Yes. And there, going to do that. Okay. I don't think that's it. Do we agree that there are two pieces? Yes. If I asked you what is the value of the function at x is equal to 1, what is your answer? Is it 1? Is it 2? Is it undefined?
It's 1.
It's 1. Why is that, Thomas?
Because when it's a closed circle, that means it includes the point.
Very good. So a closed dot here implies that the function will take on that value. So this is 1. What is the value of the function at x is equal to 2?
Four.
4, very good. So same logic, closed dot would mean we would have a value in terms of a limit. How did we find the limit last time using the calculator? So I wrote a table and we approached 2, I believe, from the left-hand side, from the right-hand side, and the values got closer and closer to one number, which I think was 4, right? Okay. We're going to use the same logic. I'm going to approach 1 from the left-hand side, okay? Which would mean starting somewhere here, I'm going to get closer and closer to 1. As you get closer and closer to 1, what value does y approach?
1.
1. Rob says 1. Do we agree? What's the function last time? X squared. I forget. It's 3x minus 2. In blue, it is last time. Oh, it is from last time, so 2.1, 1.994, something approximately equal to 4. So approaching 2 from the left-hand side, you simply got the value of the function. Things started approaching that number, which is the value of the function. Same logic, we're getting closer and closer to 1, and as x is approaching 1 from the left-hand side, the value of y is approaching 1. Good. So I'm not going to call this the value of the function, I'm going to call it the limit of the function. Good. Last time I mentioned anytime you have an asymptote, you would end up having limits. But by all means, if you have a vertical asymptote, there are two pieces. Do you agree? If there is one point somewhere, there is an arbitrary line along which the curve goes toward infinity or negative infinity. There is a break right in the middle. Yes, two pieces. Same logic. So if I get closer to 1 from the left-hand side, this is the notation, limit x is approaching 1 from the left. For this function, I'll call it g of x. We agree that that answer is 1. My question to you now is, when you approach 1 from the right-hand side, will the value of the limit be the same?
No,
Rob says no. Why not?
because the line coming from the right side is going to end up near 2.
Okay, so easier way to see this. I'm asking you to approach 1 from the right-hand side. So forget everything that happened before 1, and you've got that part. Say from positive infinity, you're getting closer to 1. The only curve that you see is that. Agreed? So as you get closer to 1 from the right, the curve is getting closer to that point. At that point is the value of the function 2. Think about what you gave me earlier. We've already established that. Is it the value of the function at x is equal to 2? I call it f. Change it to g. G. When x is equal to 1, I have 1. My question to you now is, as you approach x from the right-hand side, is the value 1? Rob said no. What is it?
It's going to be near 2.
It is going to be near 2, but it won't be exactly 2. Agreed? Why?
On the graph. 2 is an open dot, so that means it's not included.
On the graph, 2 is an open dot. The y value of 2 is open. In other words, you can get as close as possible to the value 2, but it just can't be 2. Good. This is the case where we say the function is approaching to the value 2, but it only does in the sense that the limit as you approach 1 from the right-hand side on the x-axis, you end up getting 2. So the value of the function doesn't always have to equal to the limit of the function. And by all means, a limit can be any number, or it simply can't exist. In which case, we write it as D and E. Does not exist, don't forget. And D and E, undefined, they don't mean the same thing. Good? So don't forget that. And you have come to calculus far away from algebra, so undefined and infinity are not the same. In this case, do we actually have a limit? What we did in the calculator using the table, as I went closer and closer and closer to 2 from the left-hand side, I got a number for y which was getting closer to 4. Yes? Likewise, from the right-hand side, I was approaching x slowly, and y was getting closer to 4. This end, that end, met at the same value of y. Do we agree? What is that value last time?
Approach 4.
4. Left-hand side, right-hand side, do the values, do the limits meet at the same point? Same y value. Get you. Nate, go ahead. No, Nate says no, why not? They're not the same. Left limit is 1, right limit is 2. They're not meeting at the same value for y. So in this case, a limit does not exist. So limit as x approaches 1 from the left. Limit as x approaches one from the right, and limit in general for that function, that one at the approach point does not exist. Because the limits have to meet at a single value. If it does, then we have a limit. Otherwise, no limit. Okay. 2. You can tell me, same function, limit x approaches 2 from the right-hand side. Think of what I mentioned earlier. If you are looking at x approaching 1 from the right-hand side, forget about everything on the left, right? And look at the curve. So I'm going to start here, forget about everything here, look at the curve, and tell me what the limit is. 4, okay. Any other answers? Thomas? Are you going to say 4 or 7?
Probably.
From the right?
From the right, I don't know.
Louder.
I don't know.
Why don't you know?
Well, if you look to the right of the point, there's no,
There is nothing there, correct? I said, well, if you are going to look at the value of the function from the right-hand side, forget about everything to the left of 2. Okay, forget everything. Do you see anything there? Nothing is there. There is nothing to get closer to the value of 4. In this case, it doesn't exist. What about coming from the left-hand side? Same logic, ignore everything, path to, well, there's nothing here, but what value does y approach as you get closer and closer and closer to 2?
this one's 4.
This one is 4. So there's nothing here to ignore, but whatever. So 2, you're going in this direction. As you get closer to 2 on the x-axis, the value of the function slowly climbs toward 4. It is not the value of the function is the limit. So left-hand side limit is 4. Do they meet at the same number? One side it doesn't exist, another side it is 4. Do they match up? No. If they don't match up, limit doesn't exist. Left-hand side, it is 4. Right-hand side limit does not exist. Put them together, there is no consensus. So the limit is actually DNE. Good. So one can say that the limit exists if and only if the left-hand side limit and the right-hand side limit meet at the same value. They must match up. If they don't, then you don't have a limit. Good. Time to pick up your calculator.